Hello everyone, Mr. Fritz here. In this set of videos, we're going to talk about solving trig equations with graphs. So we can have all kinds of functions that we want to solve for x, and sometimes they'll work out to be these nice, neat numbers if we're using like unit circle, trig, but sometimes it won't be so nice, and we're going to have some uglier equations, but we can still solve them, and we're going to use the graphing calculator to solve these equations. So once we get into the button pushes of how to do this, really not that difficult. But let's just dive in and do some examples. So here in this example, we want to use technology, aka a calculator, to solve for x. And here it is important to note that x is greater than or equal to 0, but also less than or equal to 8. So we're kind of given a window for these solutions. And we want to give our answers to 4 significant figures. Now this 0 to 8 thing is important because these periodic functions, they go on forever and ever and ever and ever and ever and ever and ever. And if I just said solve for x, I need some way to represent these infinite solutions. So we're only going to look for solutions between 0 and 8. So let's jump to the graphing calculator to help us solve this. So I want to figure out basically when sine of x equals 0.414. And the way that I'm going to do that is I'm actually going to graph an equation for y1 equal to sine of x, an equation for y2 equal to 0.414. And then I'm going to look for where these things intersect. So let's do that. I'm going to go over to my y equals. I'm going to graph the sine of x. And then I'm also going to graph the line y equals 0.414. And by doing that, I'm going to look for when they cross, and then whatever x values are within that window are my solutions. Now, one thing we have to be careful here is depending on whatever window I'm in, I could look at all kinds of different things. This is the standard viewing window. Maybe I have an old viewing window from a previous problem. But let's think strategically about what we want to set this particular viewing window to for this type of a problem. So let's go to the window, and I'm looking for solutions when x is between 0 and 8. So I'm going to look for an x min of 0 and an x max of 8. So actually I'm going to set those as my x min and my x max. For my y min and my y max, I'm looking for when the y values of this graph of sine of x equals just this horizontal line 0.414. So really, I don't care about much above this or below this. So let's kind of hug 0.414. So let's get a y min of just 0 and a y max of 1. So that's basically going to put 0.414 right in the middle of 0 and 1. And so now when I hit graph, I'm looking at a picture of just what I'm interested in. And by setting the window from 0 to 8, that means that every single one of these intersections is a solution. So I've got 3 solutions in this example. So what I'll do then is to find these solutions. Actually, what I'll do first is I'm going to set this up as a solution set since I have 3 answers. So I'm going to open up my solution set, x can equal. And now to actually find these intersections, I'm going to go to the second calc function, scroll down to intersect, hit enter, and now it's going to ask me for some questions. It's going to ask me a couple questions. First curve is just a way of saying what is the first graph that we're interested in. And the first graph that I care about is my blue curve. I'm not sure where it is. There's my cursor. So I'm saying yes is the first thing. The red graph is the second thing. I'm going to scroll over to the guess that or the intersection that I'm interested in. That kind of tells the calculator which one I care about. Hit enter a third time, and there's my intersection. And I'm going to 4 significant figures. So that's going to be 0.4268. That's 1. We got to get the other 2 now. So I'll do the same stuff as I did before. Second calc, intersect. First curve is the blue graph. Second curve is the red graph. And then I need to scroll over for my approximation for my intersection. Hit enter, and now my second solution is 2.71. And I want 4 significant figures. So that's 1, 2, 3, 4. So we'll round that to 2.715. 2.715. And then my final answer, or final solution, second calc, intersect, first graph, second graph, scroll on over to this guy, hit enter, and this intersection is 6.710. And close the solution. So this is it. Not necessarily like a pretty solution here. I could really couldn't have gotten like a nice fraction or an exact solution, so that's why I need to use the graph and those intersection functions. All right, so let's take a look at the second one. I want to know when the sine of 2x equals 0.162. Same exact process. I'm going to graph y equals the sine of 2x, and then graph y equals 0.162. I'll take a look at my graph. I'm going to keep those window dimensions exactly the same because I still want it from 0 to 8, and 0.162 is still between 0 and 1. So this kind of captures what I'm interested in. And now I see I've got 1, 2, 3, 4, 5, 6 of these solutions. And it should make sense that I have more of these, seeing as I have compressed my period to pi rather than 2 pi. So it makes sense to see more of these. And that's always a good thing to keep in the back of your mind. Does it make sense that I'm seeing more solutions than the typical graph? Okay, so I'm going to do the same thing as I did before. I'm going to find all of my intersections. So second, calc, intersect, first curve, second curve, scroll over, hit enter. There's my intersection, 0.08136. Okay, here are all of my solutions, all 6 of them. So hopefully you were able to get the same stuff when you were doing this on your own. Why don't you actually try another example? Very similar. I want you to graph each of these, and again, looking for solutions between 0 and 8. So pause the video, use your graphing calculator, and give this one a shot. All right, and here are my solutions. There actually was just one solution for this first example. I've grabbed it here, a screenshot from my calculator, and for the second example, there are only 2 solutions in this viewing window. So I've got both of them identified here. Now, if I were to make this out to 4 significant figures, then let's see, this one I'll go 1, 2, 3, 4, no rounding here. This is my solution, 7.585. And over here, 1, 2, 3, 4. This one's actually going to round up to 3.405. And then this one will be 1, 2, 3, 4. This one does not round up. So x equals 1.831. Those are my solutions for those 2.